In this video, we are going to solve system of linear equations by linear combinations method. Sometimes it's also called addition or elimination method, which means absolutely the same thing. The idea behind this method is that if you have two terms, like for example 2x and a negative 2x, if you add them up, it's going to give you 0. And if you look closer to those terms, you will see the same variable, the same numerical value, but the different sign. Another example would be negative y plus y equals 0. So I believe you got the idea. We are going to solve three systems of linear equations in this video, and the first one is right here. First thing what you have to do before you start working this out, you have to double check if your system, the equations are written in the standard form. It means all the variables on one side, numbers on another side, and all variables are lined up, x's under x's, y under y. And in our case, both of the equations are in standard form. Linear combination method tells us that if you are going to add two equations together, one variables are going to be eliminated. And if you are going to add these two equations, you can clearly see that negative x plus x will give us 0. So the terms with x are going to vanish. And this is what we need. So we are going to add up these two equations. Term with x will vanish. Y plus y is 2y equals negative 1 plus 5 is 4. If we divide both sides of the equation by 2, y equals 2. But this is only one variable. We need variable x. We are going to use any of those two equations, equation 1 or equation 2. We are going to use equation 2. And plug it in, y equals 2 instead of y. So x plus y, which is 2, equals 5. And if we subtract 2 from both sides of the equation, x equals 3. The answer for this system is an order pair 3 and 2. And of course, it's a very good idea and a good habit to check your answer. In order to check, we are going to plug it in, x equals 3 and y equals 2, into both of those equations. So for the equation 1, we are going to have negative x, which is negative 3, plus y, which is 2, equals negative 1. And this is correct. For the second equation, we are going to plug it in, x plus y equals 5. So x equals 3 plus y equals 2 equals 5. And this is also correct. So our answer is correct. Now let's have a look at the second system. In this case, we can also apply elimination method, but before, the first step is to check if this is equation in standard form. Yes, all variables on one side, numbers on another side, x's are lined up, y's are lined up, numbers as well. If we are going to start adding these two equations straightforward, you will see that 3x plus x is 4x, not 0. Negative 4y plus negative 4y is negative 8y, so it's not 0 again. But these two terms are very, very close to what we need. If this would be positive, that negative 4y plus positive 4y will give me 0. So I need to somehow modify this equation so I will have positive 4y. Or this one, it doesn't matter. I will work with the second one, I just like it. So what we can do, we can multiply the whole equation by negative 1. In this case, this term is going to become positive. Of course, those terms are going to change, but it's okay. Let's try. The first equation will not change at all. So I'm going to copy down this equation like it is. 3x minus 4y equals negative 16. Second equation is going to become negative x plus 4y equals 40. Now we are ready to add them up, and 3x plus negative x is going to give me 2x. Negative 4y plus 4y is going to give us 0. This is what we wanted to. Negative 16 plus 40 is just simply 24. If we divide both sides of the equation by 2, x equals 12. Now we have to solve for a y, and we are going to use again any of these two equations, and I'm going to use the first one and plug it in x, which is 12, into this equation. So 3 times x, which is 12, minus 4y equals negative 16. This one becomes 36 minus 4y equals negative 16. If we are going to subtract 36 from both sides of the equation, we are going to receive negative 4y equals negative 52. And if you divide both sides of the equation by negative 4, y equals 13. I'm pretty confident in my answers. And the answer again, let's recall, is supposed to be the order pair 12 and 13. And you must check it. Don't forget, I'm not going to spend my time on this, but you're supposed to check it. Let's have a look at this one. This system looks a little bit more complicated. It's still in the standard form. We don't have to be worried about lining up. However, if you analyze it, we do know that we need to have two opposite terms. These two terms, they have opposite signs, but numerical value is different. These two terms, they have opposite signs, but numerical value is different. It would be good if this number and this number would be the same. So we have to do it. And we can reach it by multiplying the whole equation and two equations by the numbers what are convenient for us. If we are going to multiply this equation by 4, we are going to receive this term 12x. If we are going to multiply this equation by 3, we are going to receive negative 12x. And this is exactly what we need. So let's do it one by one. So let's multiply this equation by 4, and we will receive 12x. I'm sorry, let me change the color. 12x minus 20y, so I'm distributing 4 for each of those terms, equals negative 28. Second equation, we're going to multiply by 3. Negative 12x plus 21y equals 24. Now we can add them up because 12x and negative 12x are going to cancel out. Negative 20y plus 21y is just simply y. And if you add negative 28 plus 24, it's negative 4. We found y equals negative 4, but right now we have to find x. And we are going to use any of those equations to plug it in y equals negative 4. We are going to use the first one. So 3x, because we don't know what the x is, minus 5 times negative 4 for y. And it should give me negative 7. 3x minus 5 times negative 4 is plus 20 equals negative 7. If we are going to subtract 20 from both sides of the equation, 3x equals negative 27. And if we divide both sides of the equation by 3 to isolate x, x will be equal negative 9. So our answer is the order pair negative 9 and negative 4. And again, I'm confident in my answers. I checked them before, but you're supposed to check it. Don't forget, especially in the test or quiz. Now, I'm going to erase all ink from the page, and I would like you to repeat this procedure and solve this system. Good luck.